Integers a, b, c, and d, not necessarily distinct, are chosen independently and at random from 0 to 2007 inclusive. What is the probability that AD minus BC is even? There are two general scenarios when AD minus BC is going to be even. So essentially, when you have an odd number minus another odd number, that gives you an even number. And when you have an even number minus another even number, that gives you an even number. So I want to break this down first into cases. So case one, we're going to look at this one. So AD is odd and BC is odd. And so how do you achieve that? So AD being odd, the only way for a product to be odd is if both of these numbers that are being multiplied are odd. So AD needs to be odd and B needs to be odd. A needs to be odd and D needs to be odd. And same thing here. B needs to be odd and C needs to be odd. So in terms of even and odd combos, there's only one way to for this to be true, and it's this. So case two, looking at having an even minus an even, it's going to be true that AD is even and BC is even. And there are a lot of ways this can be achieved. So one, just looking at AD, A could be even and D could be even. A could be even and D could be odd. Or A could be odd and D could be even. These combinations would allow AD to be, the product AD to be even. And same thing with BC. B could be even, C could be even. So we have three ways to pick an AD combo and three ways to pick a BC combo. So you could pick this AD pairs with that BC, or that BC, and same thing, this pairs with that, and that, or this pairs with that, and that. And we find that since there are three ways to pick this and three ways to pick that, the number of ways in which AD can be even and BC can also be even is going to be 9. There are 9 ways. So now getting back to this probability piece, what's the probability that AD minus BC is even? Well, the total number of ways to pick an even odd combo for A, B, C, and D is we just need to look at, well, A could be either even or odd, so there are 2 ways to pick for A, 2 ways to pick for B, 2 ways to pick for C, 2 ways to pick for D. It can be either even or odd. So one possible combo would be like odd, even, odd, odd. And that's a possible combination. So the total number of ways to pick an even or an odd for these numbers is going to be 2 to the 4th, which is 16. So there's 16 total ways to pick even and odd combos for A, B, C, D. And so since there are, looking at situations when AD minus BC is even, we found one way in this first case when AD is odd and BC is odd. And we found 9 ways when AD is even and BC is even. So in total, there are 1 plus 9, 10 ways to pick the AD being AD minus BC being even. And so then, therefore, that means the probability of AD minus BC being even is going to be that over the total number of ways to pick an even and odd combo. So 10 over 16, which is 5 over 8, which is that probability. So the answer is choice E.